Halina mga bata, tayo nang mag-aral sa math, walang maiiwan. At sayang mag-aral tayo nang matuto upang ika'y umasenso. Maging matyaga, maging matalino, halina mag-aral na tayo. Maging matyaga, maging matalino, halina mag-aral na tayo. Halina mag-aral na tayo. Halina, 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 mag-aral na tayo.
Magandang araw pong muli sa ating lahat. Maraming salamat po sa lahat ng Batang MANDdunong, home learning partners at mga guro na patuloy na nakatutok sa Project SOAR, series of online academic reviews for Mathematics CLAID Learning Modules, Week 8. Ako po si Ma'am Karen Sota from Andres Bonifacio Integrated School at nagpapaalala po sa inyo na para maging updated kayo sa mga video lessons weekly, huwag po kalimutang bisitahin, like at i-follow ang Mathematics Teachers Association of Mandaluyong Math Team Facebook page at mag-like, mag-share at mag-subscribe sa MTM YouTube channel. Kanina ay nasaksihan natin ang interesting na pagbabahagi ni Ma'am Josephine Jimenez ng Advanced Lessons for Grade 10. Ngayon naman, tayo nang makinig sa isa pang mahusay na guro mula naman sa masisipag na senior high school mathematics teachers of MANDdunong. Our next teacher reviewer is a graduate of Bachelor of Secondary Education, major in Mathematics at Rizal Technological University, and also a NITS earner at the National Teachers College. Grade 11, kaway-kaway. Tayo nang makinig at matuto kay Ma'am Eva Makadangdang mula sa Mandaluyong High School.
We are now in week 8 of CLAID learning modules. In this video, we will discuss Module 8A, Module 8B, and Module 8C. Let us start with Module 8A. The learning objective is represents real-life situations using logarithmic functions. Now, what is a logarithm? A logarithm is the inverse process of exponentiation. The exponential function were already discussed from the previous module. So by definition, let A, B, and C be a positive real numbers such that B should not be equal to 0. The logarithm of A with base B is denoted by log to the base B of A and is defined as C is equal to log to the base B of A if and only if A is equal to B raised to C. The exponential form, we have B raised to X equals Y, wherein B is the base and X is the exponent. The equivalent logarithmic form of this exponential form, we have log to the base B of Y equals X. Now, where is the base? So, base is located here. What about the exponent? The exponent is located here. Here are some reminders about logarithmic. First, in both logarithmic and exponential forms, B is the base. In the exponential form, C is an exponent. This implies that the logarithm is actually an exponent. Hence, logarithmic and exponential functions are inverse. Second, in the logarithmic form, log to the base B of X, X cannot be negative. Example, log to the base 3 of negative 2. Then we have the value of log to the base B can be negative. So only the value of X that cannot be negative. Let's have an example on how to rewrite exponential equation to logarithmic form. Number 1, we have 2 raised to 3 equals 8. The base is 2 while the exponent is 3. So the equivalent logarithmic form is we have log to the base of 2 of 8 equals 3. Number 2, we have 7 raised to b equals 21. Again, the base is 7 while the exponent is b. So the equivalent logarithmic form is we have log to the base of 7 of 21 is equal to b. Number 3, we have x squared equals 100. So the base is x while the exponent is 2. So the logarithmic form is log to the base of x of 100 equals 2. Number 4, we have 3 squared equals the quantity x plus 1. So what is the equivalent logarithmic form? So base again is 3 and the exponent is 2. So we have log to the base of 3 of x plus 1 equals 2. Next, number 5. We have e squared equals x. So e is the base, while 2 is the exponent. This can be written as log to the base of e of x equals 2. But wait, number 5 is different from the other example. Because this number 5, it can be written as ln x is equal to 2. Now, what does ln x means? So, ln x is a natural logarithms. Now, what is a natural logarithms? So, natural logarithms are the logarithms to the base e, which is it is approximately 2.71282 and denoted by ln, or the natural logarithm. In other words, ln x is other way of writing log to the base of e of x. Let's have an application of logarithmic function in real life situation. So usually it is when we need to measure the magnitude of the earthquake. So using the Richter scale, then the sound intensity, and then the pH level. So the formula of Richter scale, so we have m log I over s, wherein m, of course, the magnitude, and I is the intensity of the earthquake. Then we have the s is the intensity of the standard earthquake. For sound intensity, so we have dB equals 10 log I over I sub o, where the dB is the sound intensity level, while the I sound intensity, and then we have I sub o is the lowest sound intensity. Then for pH level, so we have pH equals negative log H raised to positive. So wherein H positive is the concentration of the hydrogen ions in the substance. Problem number 1, using the Richter scale, we have early in the century, the earthquake in San Francisco registered 8.3 on the Richter scale. In the same year, another earthquake was recorded in South America, and that was 4 times stronger. The question is, what was the magnitude of the earthquake in South America? So here's the solution. So of course, we will be using the Richter scale. And then the given is the magnitude of the earthquake happened in San Francisco, which is 8.3. So making this sentence into a mathematical equation, so we have that 8.3 equals log I over S. For the second sentence, so it was stated that the earthquake happened in South America is 4 times stronger than the earthquake happened in the San Francisco. So here's the mathematical equation. Okay? So using the given formula now, that the equivalent of I is 4I, so 4 times the intensity of the earthquake happened in San Francisco over S. Okay, so as you notice in this solution, so we divide the two. So based on the given properties of a logarithm that we have to subtract, so therefore we have log 4I minus log S. And we all know that it's still log 4I is it's still the process still multiplication. So we can apply the property of logarithm wherein we have to add. So as we multiply, so the equivalent is addition. Okay? So therefore, we have log 4 plus log I minus log S. Then, for log I minus log S, we can make that into a fraction. Okay? So applying the properties again of logarithmic, then we have log 4 plus log I is I, or the intensity happen in San Francisco over S, wherein we have the value which is 8.3. So therefore, we have log 4 plus 8.3. So getting the value of log 4, so we have 0.602. So plus 8.3. So adding the 2, so we have 8.9. Okay? So based on the computed value, we may conclude that the intensity of the earthquake in South America was 8.9. Okay, so using the Richter's scale. Okay, so let's have a problem for sound intensity. So the lowest sound intensity that can be heard by human is 10 raised to negative 12. So find the sound intensity level of a jackhammer that has a sound intensity of 10 raised to negative 3 watt per square meter. Okay, so the solution, so of course, we will be using the formula in computing the sound intensity. Then we have the given, so we have I equals 10 raised to negative 3, while I sub O is equal to 10 raised to 12. Okay, so substituting the equivalent value, so we have 10 log times 10 raised to negative 3 over 10 raised to negative 12. Okay, so applying the laws of exponent, that we can subtract the exponent. So 10 log 10 raised to negative 3 minus negative 12. So therefore, we have the exponent now is negative 3 plus 12. So we need to subtract. So we have 10 log 10, 9. Okay? Then, we can rewrite this as 10 log. So, yung n natin becomes an exponent also. So, is an exponent also. So, we have log 10 raised to 9 times 10. So, we have 9 times 10 is 90. So, therefore, we have the final answer which is 90 decibels. Okay? So, next problem is we have the pH level problem. So we have a chemist define the acidity or the alkalinity of a substance according to the formula. So we have pH is equal to negative log H positive, where H positive is the hydrogen ion concentration measured in moles per liter. Solution with the pH value of less than 7 are acidic. Solutions with a pH value of greater than 7 are basic. Solutions with a pH of 7, such as pure water, are neutral. Suppose that you test apple juice and find that the hydrogen ion concentration is 0.003. Now, find the pH value and determine whether the juice is basic or acidic. So we have the given. So H positive equals 0.003. Okay, so the solution now, so using the formula, so we have negative log 0.003. So we have negative times negative 3.523. Then we have 3.523. Okay, so therefore the since it is less than 7, so the pH level now is acidic. Okay, now, let us proceed to Module 8B. So we have distinguishes logarithmic function, logarithmic equation, and logarithmic inequality. Okay, so let us define first what is a logarithmic equation. So we have an equation involving logarithms. So an example, So we have log to the base of 4 of x plus 1 equals 2. Okay, next, the logarithmic inequality. So definition, an inequality involving logarithms. So here's the example. 2 log of 4 of x is less than log to the base of 4 of x plus 1. Okay? So next is the logarithmic function. So we have a function of the form f of x equals log to the base of b of x, wherein b is greater than 0 and b should not be equal to 1. Okay, so here's the example. So we have f of x equals log of to the base of 4 of x. So now, based on the given example, I know for sure that you can now easily distinguish the difference between the three. Okay, let's have an example. So we have to determine whether the given is a logarithmic function, a logarithmic equation, a logarithmic inequality, or neither. Okay, number one. So we have h of x equals log to the base of 1/2 of x. So how can we distinguish if it is a function, equation, or logarithmic inequality? Okay, so based on the given, so we have the logarithmic function. So we have, it is in the form a f of x. Okay, number two, so we have log times log the quantity of 4p minus 2 equals log the quantity negative 5p plus 2. So, of course, this is a logarithmic equation. Number 3, so we have log to the base of 2 of 2x squared plus 2 is greater than log to the base of 4 of x raised to 4. So, it uses the inequality symbol. So, therefore, it is a logarithmic inequality. Number 4, we have y equals 2 log to the base of 2 of 3x plus 1. So y or f of x is the same. So therefore, this is an example of logarithmic function. For number 5, so we have log to the base of 8 of x plus log to the base of 8 of x plus 6 equals log to the base of 8 of 5x plus 12. So, this is an example of logarithmic equation. Okay, so I hope you can now identify or easily distinguish the difference between the three. Okay, so let us proceed now to Module 8C. So the learning objective is solves logarithmic equations and inequalities. Okay, so we need the following properties for us to solve the logarithmic equation and inequality. Okay, so let b and x be real numbers such that b is greater than 0. So take note for that. And b should not be equal to positive 1. Okay, so let's have property number 1. So we have log to the base b of 1 is equal to 0. Okay, then based on the exponential that any b raised to 0 is equal to 1 or any number raised to 0 is equal to 1. Okay, next we have the property number 2. So log to the base b of b equals 1. Okay, so b raised to 1 equals b. So under the basic knowledge of the algebra, that we know that any number raised to 1, it's still the answer itself. Okay? So next, property number 3. So we have log to the base b of b raised to x, okay, equals x, and can be written as b raised to log to the base b of x. Okay, so we call this as the inverse property. Then we also have the property number 4. So we have log to the base b of x equals log to the base b of y. Okay, so for property number 4, it may conclude that x is equal to y. Okay? So we call this as the one-to-one property. Okay, next, we also have the log to the base of A of C equals log to the base B of C over log to the base B of A. So, in some cases, we may use this property if they have a different base. So, what we call that chains base formula. Okay. Next, we also have property number 6. So we have log to the base of A of B equals log equals 1 over log to the base B of A. Okay. So don't forget these properties. So there are also laws of logarithm. So here's the basic laws of logarithm. So let B a positive number not equal to 1. So let x and y be any positive number and n be any real number. Then, okay, so we have the first law of logarithm. So we have the product. So we have log to the base b of x, y equals, so product then becomes addition. So we have log to the base b of x plus log to the base b of y. Okay, we also have the logarithm of a quotient. So the second law. So we have log to the base b of x over y. So a while ago, dun sa first example natin, dun sa problem solving while ago, that when we divide the equivalent is subtraction. So we have log to the base b of x equal minus log to the base b of y. So we also have the logarithm of a power. Okay, so we have log to the base b of x raised to n. So can be written as n log to the base b of x. Okay, so these are the very important law of logarithm for us, laws of logarithm, and it may help us in solving the logarithmic equation and inequality. So, in solving logarithmic equation, so we have two types of logarithmic equation. So we have the first one, we have log to the base b of m equals log to the base b of n. Okay, then the other one is we have log to the base b of m equals n. Okay, so as you notice, the first type is both have log, while the other one is not. Okay, now how can we solve the equation if the logarithmic equation, if it is what it is written in this type? So first is, if both have log, then m is equal to n. While if not, then m, or we may rewrite into exponential form. Okay? So let's have now example in solving the logarithmic equation. So we have log to the base of 3 of 4x minus 1 equals log to the base of 3 of 2x plus 3. So since the problem has only two logarithms on opposite sides of the equal sign, the problem can be solved by dropping the logarithms. And based on the two types of logarithmic equation, the log to the base of b of m equals log to the base of b of n, that m is equal to n. So therefore, we have 4x minus 1 plus 2x plus 3. Now, using the SPE or the subtraction property of equality, we may subtract each sides by 2x. So we have 4x minus 1 minus 2x equals 2x plus 3 minus 2x. So 2x minus 2x is now 0. So we have now 4x minus 2x minus 1 equals 3. Then, using the APE or the addition property of equality, so we need to add both sides again by 1. So we have negative 1 plus 1 now becomes 0. So 4x minus 2x is 2x. Then 3 plus 1 now is equal to 4. Then divide both sides by 2. Then x now is equal to 2. And we need to check if the computed x value is the solution of this logarithmic equation. So by using the original equation, so we need to substitute all x value by positive 2. So therefore, we have log to the base of 3 of 4. So x now becomes 2. So 4 times 2 minus 1. Then on the other side, so we have log to the base of 3 of 2 times 2 plus 3. So 4 times 2 now is equal to 8, while 2 times 2 is a 4, and 8 minus 1 is 7, while 4 plus 3 is 7. Okay? So as you notice, we arrive with the same answer on both sides of the equal sign. So therefore, we may conclude that the solution of this logarithmic equation is 2. Okay, so let's have example number 2. So we have log to the base of 5 of 4x plus 11 equals 2. So as you notice, in this example, there is no logarithm on the other side. So first, and based on the two types of logarithmic equation, the log to the base of b of m equals n can be written into exponential form, which is m is equal to b raised to n. Okay? So, rewrite the problem in exponential form by moving the base of the logarithm on the other side. Okay? So, therefore, we have 4x plus 11 equals 5 squared. And we have 4x plus 11 is now the squared of 5 is 25. And using again the SPE, so we have 4x plus 11 minus 11 is equal to 25 minus 11. So 11 minus 11 is now 0. So we have 4x is equal to 14. So divide both sides. So 14, 20, that is 25 minus 11. So divide both sides by 4. So we have 14 over 4. Reduce it to lowest term. So we have 7 halves or 7 over 2. Again, so we need to check again if the computed x value is the solution of this logarithmic equation. So we have 4x plus 11 equals 5 squared. Okay, so we can go directly to the, without using the logarithm. It can be also. So we have x now is 7 halves. So we have 4 times 7 over 2 plus 11 is equal to 25. Okay? So 4 and 2 are divisible by 2. So we have 2. How many 2 are there in 4? So we have 2 and 2 for 1. Then we have to multiply. So 2 times 7 is now equal to 14 plus 11 is equal to 25. So 14 plus 11 is 25. Okay? So therefore, we may conclude that the solution of this logarithmic equation is 7 halves or 7 over 2. Okay? Example number 3. We have log to the base of 8 of x plus log to the base of 8 of x plus 6 is equal to log to the base of 8 of 5x plus 12. So as you notice, both sides of the equal sign has a logarithm. So, meaning m is equal to n. Now, by inspecting the given, as you notice that we add log to the base of 8 of x plus log to the base of 8 of x plus 6. So, we may apply the property of the logarithm wherein log to the base of xy is equal to log to the base of x plus log to the base of b of y. So, we have now log to the base of 8 of x times log to the base of x plus 6 is equal to, so we have log to the base of 8 of 5x plus 12. Okay, so again, dropping the logarithm. So we have now x times x plus 6 equals 5x plus 12. Okay, getting the product of x times x plus 6, we have x squared plus 6x equals 5x plus 12. Okay, so we have to subtract both sides by 5x and at the same time subtract both sides by 12. So therefore, we have 5x, negative 5x now 0, and 12, then negative 12 now is 0. So we have x squared plus x minus 12 is equal to 0. So by factorization, okay, so we have to think a number that uh, when we multiply, we will get negative 12. And when we add, we will get the middle term, which is 1. So that is x minus 3 times x plus 4 is equal to 0. Okay? So this time, we have two possible solution of the logarithmic equation. So we have 3 or negative 4. But take note, we said a while ago that the value of x should not be negative. So therefore, by checking, by using the value of x, which is 3, so we have log to the base of 8 of x, okay, wherein x is now equal to 3. So we have log to the base of 8 of 3 plus log to the base of 8 of 3 plus 6 equals log to the base of 8 of 5 times 3 plus 12. So we have now log to the base of 3 of 8 of 3 plus log to the base of 8 of 9 equals log to the base of 8 of 15 plus 12. And we need to multiply 3 times 9. So again, applying the properties of logarithm. So we have 3 times 9 is 27. So as you notice that we arrive on both sides of the equation with the same answer, then we may conclude that the solution is 3, but not negative 4. Again, negative is not a possible value, or it is the restriction of the logarithm not to have a negative numbers. Okay? So, proceed to number 4. So, we have the ln of 3x plus 11 is equal to 4. Okay? So, again, this is a natural logarithm. So, the solution, so of course, as you notice, there's no natural logarithm on the other side. So therefore, we may rewrite this in exponential form. So we have this 3x plus 11 is equal to e raised to 4. Then, we have 3x plus 11, then the equivalent of e raised to 4 is 54.598. Okay? So therefore, we have again to subtract both sides by 11. So we have positive 11, negative 11 now is equal to 0. Okay? So therefore, we have now 3x equals 43.598 Okay, divide both sides by 3. Then we have x now is equal to 14.533. So again, we need to check to know if the computed x value is the solution of the logarithmic equation. So we have ln of 3 times 12.533 plus 11 is equal to 4. Okay, so get now the ln of 54.599 using your scientific calculator, then we arrive with 4. Okay, so based on the computed value, the solution is of the logarithmic equation is 14.533. Okay? So, let's have example number 5. Log to the base of 2 of x plus 1 plus log to the base of 2 of x minus 1 is equal to 3. So, the operation involved is addition, and by applying the laws of logarithm, then we can write this as a multiplication. So therefore, we have log to the base of 2 of x plus 1 times x minus 1 is equal to 3. Now, since the other side doesn't have any logarithms, then we can solve this logarithmic equation by rewriting it into exponential form. Okay? So therefore, we have x plus 1 times x minus 1 is equal to 2 raised to 3. Getting the product of x plus 1 and x minus 1, we have x squared minus 1. Then the cube of 2 is 8. Next is, we have to subtract both sides by negative 8. So we have x squared minus 1 minus 8 is equal to 8 minus 8. Then, negative 1 minus 8 is negative 9, while 8 minus 8 is 0. So we have x squared minus 9 is now equal to 0. So, since this is a square of a binomial and we can factor this using sum and difference of two terms, so by getting the square root of the first term and then the last term, so we have now x plus 3 times the quantity x minus 3 is equal to 0. So, based on the factors, we may equate it's a factor into 0. So, x now is equal to negative 3 and x is equal to positive 3. Now, based on the restriction of logarithms that the value of x should not be equal to negative 3, so therefore, we consider 3 as a possible solution of this logarithmic equation. So by checking, using the original equation and substituting the x value which is 3, so we have now log to the base of 2 of 3 plus 1 plus log to the base of 2 of 3 minus 1 is equal to 3. So 3 plus 1 is equal to 4, 3 minus 1 is equal to 2. So therefore, we have now log to the base of 2 of 4 plus log to the base of 2 is equal to 3. As you notice, we may use the properties of logarithm, okay, to simplify this answer, this log to the base of 2 of 4 and log to the base of 2 of 2. So therefore, we have now log to the base of 2 of 2 raised to 2 plus 1. And log to the base of 2 is 1. So therefore, we have 2 plus 1 is equal to 3. And 2 plus 1 is 3. So 3 is equal to 3. Okay? So based on the computed value by checking, we may conclude that the solution of this logarithmic equation is 3. Solving logarithmic inequalities. If b is greater than 1 and x is greater than y, then log to the base of b of x is greater than log to the base of b of y. if b is greater than 0 but less than 1 and x is greater than y, then log to the base of b of x is less than log to the base of b of y. So what does it mean? Going back to the first statement, that if b is greater than 1, then x is greater than y, okay? So we may conclude that the symbol of inequality may retain. If b is greater than 0 but less than positive 1 or less than 1, okay, the inequality symbol may reverse. Okay, so take note for that. Okay, let's have example number 1. Log to the base of 2 of 3x plus 2 is less than log to the base of 2 of 2x plus 5. First thing to consider in solving the logarithmic inequalities is to check the base. So based on this example, base is greater than 1. So meaning that the inequality symbol is retained. So let us now solve. So by inspecting the given, both sides of the inequality has logarithm. So we can solve this by dropping the logarithm. So we have now 3x plus 2 is less than 2x plus 5. So we need to subtract both sides by 2x and at the same time, positive 2. So we have 3x minus 2x, then 5 minus 2. 3x minus 2x is x, while 5 minus 2 is 3. So we have now x is greater than 3. So both sides of the logarithm also has a restriction. So we have 3x plus 2 is greater than 0. So we have now 3x is greater than negative 2. So divide both sides by 3. So we have now x is greater than negative 2. On the other side of the inequality, so we have 2x plus 5 is greater than 0. So we have now 2x is greater than negative 5. So divide both sides 2. So we have x is greater than negative 5. Then, we need to construct a number line, then plot the restrictions. So we have 3, we have negative 2/3, then we have negative 5 halves. On the first, we have x is greater than 3. Sorry, x is less than 3 rather. So the arrow is going to the left. Then, x is greater than negative 2/3. Okay? Then we have arrow going to the right. Then the last one is x is greater than negative 5 halves. So meaning the arrow going to the right. Check now the three lines. We can consider the solution of these logarithmic inequalities based on the three lines. So as you notice on this shaded lines, that from negative 2/3 to positive 3 is the possible solution of the logarithmic inequality. So we may conclude now that the solution is negative 2/3 positive 3. Okay? In interval notation. Next, number 2. Let's have example number 2. We have log to the base of 1/2 of x plus 3 is greater than log to the base of 1/2 of 2x plus 1. By inspecting the base is greater than 0 but less than 1, meaning that the inequality symbol may reverse. And as you notice, both sides of the inequality has logarithm. So we can solve this by dropping the logarithm. So therefore, we have x plus 3 is now less than 2x plus 1. We can subtract x and 1 on both sides. So we have 3 minus 1 is now less than 2x minus x. Then 3 minus 1 is 2, while 2x minus x is x. So we have 2 is less than x. Since there's also a restriction on both logarithms, so we have x plus 3 is greater than 0. Then we have x is greater than negative 3. On the other side, so we have 2x plus 1 is greater than 0, and we have 2x is greater than negative 1, dividing both sides by 2, so we have x is greater than negative 1 half, rather. Then we have to construct a number line. Plotting the 3 restriction, we have 2, we have negative 1 half, and we have negative 3. Then it says there that 2 is greater than x. So we have 2 is greater than x. While the other one is we have x is greater than negative 1 half. Then x is also greater than negative 3. Okay? So therefore, we will consider the part of the number line wherein the 3 lines may appear. So we have this one, it is greater than 2. So we may conclude that the solution of this logarithmic inequality is 2 infinity. Let's have example number 3. Log to the base of 5 of x is less than or equal to 2. The base is greater than 1. So meaning that the inequality symbol is retained. So let's have the solution. So we have log to the base of 5 of x is less than 2. Then we have log to the base of 5 of x. So as you notice that we have log to the base of 5 of 5 since based on the properties of logarithm, that is equal to 1. So it does not affect the original inequality. So therefore, we have now log to the base of 5 of x. Okay, then we have log to the base of 5 is squared. Okay, so we have now x is less than or equal to 5 squared. And the square root of 5 is 25. Okay, so based on the restriction, so we have x is greater than 0. Okay, so we need to construct a number line plotting the two restrictions. So we have 25 and then the other side is 0. So x is less than or equal to 25, so shaded and going to the left. While the other one is x is greater than 0, and since there's no equal sign, then unshaded and going to the right. So here's now the part of the number line wherein the two lines coincide. So we have from 0 to 25. So meaning that the solution of this logarithmic inequality is we have round bracket 0, then 25 square bracket. Okay? So I hope you understand solving logarithmic inequality. Let's have example number 4. Log to the base of 2 of 2x plus 1 is greater than log to the base of 2 of x plus 3. So base is greater than 1. So meaning that the inequality is retained. And both sides of the inequalities has logarithm, so simply we can drop the logarithm. Therefore, we have now 2x plus 1 is greater than x plus 3. Then we can subtract both sides by x and at the same time 1. So we have now 2x minus x is greater than x minus 1. 2x minus x is x, and 3 minus 1 is 2. So we have x is greater than 2. So again, both logarithms have restriction. So the first one is we have x is greater than negative 1. Then the other one is x is greater than negative 3. But we may not consider this since it makes the logarithmic inequality false. So therefore, the only restriction will be 2. So it was stated there that x is greater than 2. So unshaded since there's no equal sign and going to the right. Okay? So therefore, these are the possible solution now of the logarithmic inequality. So the solution now is round bracket 2 positive infinity. That ends my video presentation. Thank you for watching. By the way, I am Miss Eva Makadangdang from MANDdunong High School, Senior High School Department.